welcome to this session about simulation-driven industry, the case of maritime and shipbuilding. Here with me remotely we have two important speakers, Bas Buchner, the president of MARIN, and Luca Isgro, the head of simulation business unit at Cetena. Why this session, why this panel? We think that simulations are going to be important in the next decade, in the years to come, for a number of industries, and we wanted to give our view about the maritime industry, especially because nowadays, since the birth of high-performance computing are becoming more and more important for the designing phase and also for the operation phase of ships and of many other industries. I briefly introduce our guests, starting with Dr. Buchner. Dr. Buchner is now the president of MARIN, that is the Maritime Research Institute of Netherlands, which he joined as project manager, then went up to president. He has a PhD that he got in 2002, and he was also a visiting professor at the University of Newcastle upon Tyne, and is author of more than 50 papers about simulations. And Luca Isgro from Cetena is now the head of the simulation business unit at Cetena. He started to work as a freelance IT consultant in 1994. Then he founded his own startup that dealt with simulations, IBR Sistemi. And finally, in 2008, the startup was acquired by Cetena, and he joined the team there. Welcome to the two of you. Can you hear me and everything works fine?
Yes, it does.
Yes. Yes.
Perfect. I would like to start by asking some questions that I hope you will be able to answer during your talks, and that are in the next slide. That basically will set a bit the stage for what we are going to be discussing in the next 40 minutes. Basically, where we are, the questions that we would like to discuss, that I would like you to discuss during this talk, are about the status quo. So where we are in terms of simulation usage in shipbuilding, also taking into account the historical development of the past 20 years, basically, and which are the most promising applications that we see now and that we will see in 5 years from now. So what are going to be, what is the next big thing? What are going to be the disruptions coming in our industries? And finally, since we are also attending or we are discussing this topic in a forum that is dedicated to showcase the importance of science and technology for the society, just a final questions about the key benefits for that using simulations will provide to the general public and to the society at large. So I will start by giving the floor to Dr. Buchner.
Thank you very much,
the stage is yours.
Chairman. Can you hear me?
Perfectly, thank you.
Okay, very good. So hello, good morning from the Netherlands. Ladies and gentlemen, I'm very sorry that I cannot join you in your lovely city, but I'm happy we can still share our ideas about this topic, simulation-driven industry, the case for shipbuilding and maritime. And I would like to start with a bit of a historical background to show that any time needs its own tools. And for that, I go back around 150 years to Rear Admiral Tideman, as we would say, the head of naval shipbuilding of our Royal Netherlands Navy. And he had two challenges. The first one was the transfer from wood to steel and also from sail to steam. And this gentleman, and he was a scientist, did two important things. He started a shipyard in the Netherlands to build steel ships. We were not able to do that at that time. But he also started the second model basin in the world. And that model basin was very important to make this technological step from wood to steel and from sail to steam. And later, the Royal Netherlands Navy was one of the 5 founding fathers of our institute in the 1930s, as you can see on this picture. So they realized that model testing at that time was vital for the ships they needed. And that resulted in the present institute, which I'm heading at the moment. And what you can see here is a picture of our large facilities. Still a lot of real facilities, model basins, but also we are working on the facilities of the future. And if I look to our future challenges and the tools we have 150 years later, I see the following. We see the energy transition, we see the need for more safe shipping, we see robotization or robotization, and finally the topic of the day, the digitalization. And they all work together to come to better ships. And as MARIN, we made this picture of the sort of the sea of the future, and we redefined our mission by saying we want, with our technology, with our knowledge, we want to make ships more clean, more safe and smart, and to contribute to a sustainable use of the seas. And we came with a new slogan, Better Ships, Blue Oceans, because it's not just about knowledge or about digitalization. In the end, it should be relevant for better ships, more safe ships, more clean ships, and for a sustainable use of the oceans. And if I then look to the tools we use for that, we use a combination of 4 tools from concept development to design. You see simulations, you see still model testing, you see the applications of simulators, the human in the loop virtual reality, and finally data science monitoring of real life. And we do that from concept development, from the first idea to supporting the real operation. And if I focus on simulations first, of course we all realize that CFD has become a hugely important tool in recent decades and will be important. You see here an example of rotating propellers interacting with the hull, with the rudders and things like that. So a very important tool for design. And nowadays we can also do that in waves. So step by step you see that simple model tests are taking over by simulations. That applies for viscous effects but also for wave effects. You see an example here of our Conflow tool, a volume of fluid code for small ships, ribs in high waves, and you see the complexity. And what you see here is an example of a model test of green water on a ship. On the left-hand side, you see the model test. On the right-hand side, you see the simulation. And below, you also see the measurement of the waves, the simulation of the waves, as well as the impact pressures. And then you realize what sort of major steps we made in recent years. And this is very relevant for the design. And just to give you a final example, and that is really the strength of simulations, is that CFD helps us to understand the design better. This is a CFD calculation of a submarine, and this analysis was there to check the inflow, the load on the aft rudder as function of the inflow. And what they realized when they were doing this analysis, that when this angle of attack was increasing, the moment on this aft rudder was at a certain moment dropping off. And then by CFD they realized, when looking to the vortices that came from this control plane on the sail, that is actually interacting at the stern with the rudder, and that gives flow separation, explaining the behavior. So the detailed flow analysis in CFD helps us to come up with better designs and operations. But there's one other step I want to discuss, and that is CFD is not just replacing model testing, and model testing will be there for a long time, but it also helps us to optimize ship design. And that is the case of the simulation-driven design, because we then can look to multi-objectives, not just one loading condition at one speed, but many speeds, many loading conditions in waves, etc. So we can use these tools for optimization. And for that we need geometry tools, existing tools which you can add with your own modifications. You need gridding and you need solvers. And in this type of optimization tools you can combine CFD, for instance, with time domain or potential flow codes. And to just give you an example, this is work our colleagues have done on the optimization of an energy saving device. By parametric optimization, the size, the pitch angles, the camber, we did variations which in the end resulted in a large cloud of possible design options, and using a Pareto front you can then determine your optimum. And that is very important, and here you see the same variation in CFD. So by parametric variation you can optimize the system, and in this case we were able, for a large range of applications and conditions, to have a 4% reduction in power consumption. So that's one thing, CFD. The other thing I would like to discuss with you is the topic of the application of simulators. And simulators are typically between design and the operation. And just to give you an example, this is a project we did a few years ago for an offshore oil and gas company, where they had to install a very heavy 10,000s of ton deck on a spar structure. And simulations allow you to bring the engineers together with the operational people for mission rehearsal, so that people can talk about their operation, they can optimize the operation. So this is what you see here is the simulation at MARIN Simulators, and this is in the end how it happened. And we got a very positive response back from our client. They actually said, yes, we really changed the approach based on the simulations, and that's made it safe and efficient. Another example recent is the HMS Queen Elizabeth, the large aircraft carrier of the Royal Navy. And before they entered the port of Portsmouth for the first time, the bridge team, the pilots, the commanding team came to MARIN, and they did this whole operation. And finally they were there, and they did it safely with thousands of people on the quay. And it's very nice what the commander, you see him here in the center, said at the end. It's a Commodore, and he said, the simulator stimulates cooperation, competence and confidence. And I think that is a key to the use of simulators between design and operation. So if you look to design and operation and the use of simulators, we see they are the objective for simulator application, education and training, mission rehearsal, and analysis and improvement of the individual and team performance. And our latest development in this field is focused on small ships, which have very large motions and heavy loads on the team. And to limit the loads on the people, to develop a tool for training, we developed this moving simulator. And you can see it here in this movie, and you see a Dutch marine sailing in heavy waves. And this type of simulator allows these people to build up their training, to do things they can't do in reality safely, and then apply this type of technology for a safe operation, but also for design. So if I go back to that, you see here this line of simulations, testing, simulators, and reality. And here you see another example where I show this. And in this case still, the simulator applications between design and operation. What we see nowadays more and more, that there is a shift towards an earlier application of virtual reality in simulators, in the conceptual design between concept and development and design. One of the examples is this. This is vertical prototyping. This is a ship we were testing, model testing, but they brought on our simulator the DP system, the real hardware. They brought in the system to bring people on board from this ship onto this wind turbine, and this all in a closed loop simulation allowed the designers to optimize the design. But on the other end, this simulator is also available now for training of the crews. Now you see here the simulation, and here I recently found on the right-hand side the real thing. So on the left-hand side you see the simulation, on the right-hand side you see the real thing, and they are very close. And that allows us, and this is a picture from our Royal Netherlands Navy, where they are developing a combat support ship doing, for instance, replenishment at sea, that this type of methodologies don't only allow to analyze the ship, but also analyze the ship in its environment, the interaction with other ships. So you can really come to a better ship, but also to a better operation. So the simulators are also between design and concept. So if you look to that, the objectives are the development of operational concepts, fleets, operational testing and evaluation of new systems with hardware in the loop, the development and verification of design specifications, what does the number actually mean if you do an analysis, and experience the digital or virtual ship before it is built. And that's to support that development, we are at the moment at MARIN developing a new 7 Oceans Simulator Center. It is a simulator center with spherical simulators so that you can look around, up and down, fully around, but the whole objective of this simulator center is to come to safe and efficient maritime operations, bringing people in the loop and confronting them with the sea, but also with the behavior of their ship. And these will not just be normal bridge simulators. We will have virtual mixed reality using haptic gloves, motion capturing, treadmills. So we are stepping on board of the ship in a virtual manner to make sure that the crew can work with it, but also work with it in complex conditions and talk to the designers. So if I summarize, MARIN's mission is cleaner, safer, smarter ships, sustainable use of the seas. We do this with all our tools from concept to operation. We support this with our knowledge about the ship, resistance and propulsion, stability, seakeeping, maneuvering of the ship. We have chosen 4 spearheads: zero emission, blue growth, operations and human factors, and autonomy and decision support. But the key enabling technologies of computational fluid dynamics, time domain simulations, and data science are all supporting this simulation-driven design and operation. And my final note is the following. I think in the next 5 to 10 years we make another step. And we all talk about digital twins, of course, but still we think at the moment mainly from a model we make, an understanding of physics that brings us to reality, and then the data is the feedback. And I believe that in the next decades, you will see that the data-driven methodology, so data itself, becomes a very important factor in the modeling of our future designs. Thank you very much.
Thank you, Bas. It was a wonderful presentation, and I think he gave us a complete overview of what we were talking about. I leave the mic and the stage now to Luca, if he can hear us.
Yes, yeah.
Hi, Luca.
Yes, I show you. Okay, can you hear me?
Perfectly, thank you.
And can you see my presentation?
Yes.
Okay, perfect.
20 minutes for you.
Okay. Good morning. I'm Luca Isgro, It's a pleasure for me to be here today to talk about our experience in simulation solution and its application. I'm the responsible of simulation solution for Cetena. Cetena is a Fincantieri company, and it's the Fincantieri's research center. Cetena was born in the 1962 and has a mission to use the base research to find a solution for industry. Some Cetena activities use simulation technology from laboratory analysis to training solution. When we talk about simulation, one of definition is an approximate imitation of the operation of a process or system. But the simulation is a natural brain process. In fact, man continually creates simulation in his mind using the imagination to understand and predict his actions. From the simple prediction of a simple event to the imagination of a performance before a sporting or artistic event, our mind uses simulation ability because it is designed and optimized to simulate. For this reason, it's very easy to understand the concept of simulation. And in fact, the simulation often becomes the most effective and immediate way to understand our reality. There are many kinds of simulation, but today when we talk about simulation, we refer to maritime real-time simulation that can be applied in different applications and fields. We identify four main applications: training system for maritime and naval application, test bed, which means to use the simulation system to test, verify, and validate equipment, entity, and procedures, maneuver simulator for port assessment, and marketing and promotion, where the simulation system becomes the most simple way to show and present a product. The training system, the simulation system for training, have a lot of advantages. Often, sea operation can be dangerous. Using simulator allow, for example, to face the stormy sea or make a mooring with 50 knots of wind, or have a fight mission against other entities without any kind of risk. Obviously, the cost of a simulator operation is infinitesimal compared to a mission on the real ship. With a simulator, you can do joint mission in very complex scenario. And it is possible to do any kind of exercise to cooperate, compete, or fight with other entities involved in the same scenario. The use of simulator for testbed allows to verify and validate different kinds of equipment, entities, or procedure. For example, we can do the preliminary test of a new kind of radar, reducing the number of sea trials and relative costs. Or we can test the procedure to defend a specific port area. Or another example is that we can use virtual reality equipment to test the ergonomics of a new concept of a ship command bridge. Cetena has used the simulation system for port assessment for more than 20 years. We can check the compatibility between ship and port. And for example, it's also possible to check the compatibility between a new ship that is under construction with a new project of a new port of a new specific dock. use the simulation system for marketing and promotion have a lot of advantages. It can be a very high impact display. For example, Fincantieri brings a very big bridge simulator to various exhibitions around the world to attract the visitor and to give them the opportunity to test his ship or equipment. A very big added value is that the customer can see and touch the product also when the product is not available or it's only a project. To realize our simulation systems, we developed MANTA, Multiplayer Advanced Networking Training Architecture. To tell the truth, we start with the logo and the name, and afterward we search for the words for a likely acronym. But MANTA is a suite of software and hardware products to realize very large kind of simulation system. MANTA is developed respecting the latest generation standards. It is designed to be modular, reconfigurable, expandable, and interoperable. It has an open architecture that allows to connect to other simulation systems in compliance with all distributed simulation standards, such as DIS or HLA. It also ready to be connected to real equipment using industrial standards connection system, like for example CAN bus, or specific protocols such as NMEA, Asterix, and so on. MANTA is based on most advanced commercial hardware and software, and it is continuously updated in physics algorithms, computer graphical, and virtual environments. It is important to emphasize that Cetena performing the sea trials of all ships produced by Fincantieri. All the data collected during the sea trials power our physics engine, which are continuously update and validate. MANTA is also used for Cetena consultancy and services activity, like for example, the port assessment. With MANTA, it's possible to simulate any kind of entity. For example, big ship, fast boat, helicopter, underwater vehicle, and any kind of equipment like conning, radar, electronic chart, communication, etc. Summarizing, it is possible to simulate any kind of entities and equipment used in maritime domain. MANTA allows to build many different solutions, from desktop to full mission simulator, that can work individually or connected in a multiplayer and multi-role simulation. Desktop solution, it's mainly used for individual use. Console solution is used to simulate a specific console or equipment. Full motion solution use the 6 degree of freedom motion platform to recreate the same movement of the simulated entities. The full bridge solution is used to simulate all activities of a common bridge ship, and the full mission solution integrates the simulator all main naval ship rule, conduction, propulsion, and combat system. Now I show you some of our case history. One of our best military customers of training simulation system is the Italian Navy, that uses different kind of simulator. On the left, you can see a classroom for individual navigation training. And on the right, you can see a full mission simulator that integrates also the machinery control room simulator and combat system simulator. Another example of training simulation system is the full bridge STCW certified that we realized for Italian Shipping Academy, located in Genoa. This is an example of the use of simulation system for preliminary analysis and validation of drone and RIB procedures involved in an Ocean 2020 project. And this is our laboratory when we do the port assessment analysis. The customer can use also all the command bridge equipment and can use also the VR helmet to improve the feeling of the reality and detect the correct distance when, for example, try to mooring from the ship wing. And this is the last Fincantieri booth, the Euronaval in Paris in the 2018. In this case, we realize a simulator with a LED wall visualization system, which has a base of 50 meters, a very big impact system. And the last one, case histories, is our Simon project. In Simon project, we have combined simulation knowledge with the real world. For the new San Giorgio Bridge in Genoa, Cetena has created the monitoring system to continuously check its condition. In the Simon project, this data power the digital twin of the bridge in order to be able to realize predictive analysis on the state of the bridge. And also, through the augmented reality devices, it's possible to do maintenance of the bridge system in an effectively and efficiently way. Simulation applied to digital twin and the use of augmented reality is one of the most important features future development. Okay.
Thank you very much, Luca. Since we have another, let's say, the final 10 minutes, I would like to ask a final question to both of you. That was basically a summary, a wrap-up of what you told us. You showcased a lot of important applications for the maritime industry for simulations, and you also hinted at some of the benefits that those simulations will have for society. So, for example, we heard about simulating for creating ships that are becoming greener, or simulating for optimizing operations and therefore ensuring a higher safety both for the crew of the ships, but also for the people operating the shipyards and so for the cities in general. I would like, if you can, you to elaborate a bit more about this, because I think that both of you hinted to the fact that in the next decade, in the near future, simulations are becoming more and more important. Therefore, we can also expect, as a society, more benefits out of them, more benefits out of the fact that shipbuilders, ship operators, and also yards will use simulations for their day-to-day activities. What is your take about the benefits that the society will gain the next decade from this continuous improvement in the simulation industry? I will start again with Dr. Bruckner, and then I'll move to Luca. Please.
Thank you, Nicola. Very relevant question. I think there is a very important application in clean shipping, the operation of the ship. But I think the major steps are at the moment in the safe use of ships at sea. Shipping safety is still a major concern. Even this week, a ship was capsized. And that is what we see is that a lot of ship accidents are a combination of what's happening at the ship and how the crew is responding to that. And what I think the most important contribution of simulation technology is to the societal challenges is that we can improve safety by involving the users of the ship already in an early design phase. So we can take their input to the design of the ship, and we can use also the simulation as a discussion platform between engineers and operational people who have another way of looking to things. And it's also very important that engineers realize how people are using their ships. So I think that is a very important step, and that will, and also Luca explained a lot of very relevant things about that, is by building digital twins in an early phase, allow people to explore the ship, to sail with it in complex conditions in ports, and make sure that in the end the ship can do its operation safely and in an efficient and clean manner. I would like to leave it to that at the moment.
Thank you. Thank you very much for your answer. And I think that this is particularly relevant for the, let's say, the forum in which we are held in this discussion, because at the end it has to do a lot with the link between science, technology, and society. Luca, would you like to take on from this and give your point of view about how society will benefit from the increasing use of simulations in industry and in shipbuilding in particular?
Yes, I agree with Bas, because I think that the improvement of digital twins that integrate the simulation system will be able to optimize the use of ship in the future. For example, regarding the optimization of the consumption or the optimization of their path. But besides the digital twin can reproduce the port and can improve the safety of the port and their business. I think that digital twin cover in the future will cover all the industrial activity, especially in maritime domain. And I think that this is the key to improve and optimize all the activities around these fields.
Am I allowed to add to that? Because for people who are not maritime, people don't often realize that ships are typically one-offs or in very small series. So we are sailing with prototypes. And that means that the digital twin allows us to test these prototypes because they are so big in an early phase. So for the maritime sector, it's a bit different from the automotive sector where you have so many cars. But ships are unique things, and it allows us to optimize the unique things before steel is cut.
Yeah, basically,
yes,
every pilot is a test driver in the shipbuilding. So it's like you take the first car out of the manufacturing chain and you drive it on the road immediately. So it's a bit different, and of course simulations can help in diminishing the problems and the risks that you will encounter. I was intrigued, Luca, by you pointing out the role that Cetena had for the San Giorgio Bridge And I was wondering whether you can give us some more details. We are exiting, of course, from the shipbuilding industries, but I think it's nice to see that at the end simulations are cross-cutting applications that can transfer the benefits that one can gain from an industry to another one. So just out of curiosity, if you can give us some more details about the bridge and how the bridge works, the monitoring system that you set up in the bridge works.
Yes, in this case, Cetena reuse the experience in ship monitoring system, applying it on the bridge construction. There are a lot of meters of fiber that connect more than 500 different sensors on the bridge to monitoring all the structure of the bridge, and we have the idea in this case with the Simon project to realize the digital twin of the bridge and collect all this data acquired by a sensor to realize a digital twin that combine the real information in continuously, and that give the opportunity to create and analyzes this data for predict the state of the bridge in different situations. For example, if we can check the condition of the bridge in different weather conditions, and we can simulate the state for a specific different kind of traffic during different kind of state condition, environment condition. And also, in this case, we use the ER technology to realize a system to maintain this very big infrastructure of sensor using the augmented reality to find the position of the correct sensor in a new way and efficiently way, because the operator can use a specific Google to find the sensor and to have all the information of the sensor and the history of the sensor to make a good maintenance and to check its state.
Thank you very much. We are at the end of our slot today. It was a pleasure to host both of you, and I thank you for your valuable contribution. And I hope to see you in person rather soon. Unfortunately, it was not possible at this time. I will use the last 20 seconds of this slot just to thank you, the technical staff here at ESOF, because they did an amazing job by being able to manage this hybrid format for all these talks. Thank you, guys, and see you soon.
See you soon.
See you soon.